Hello, hi student. Good evening. So today we are going to see the convolution in discrete time signal. Okay, how to do the convolution of two discrete time signal. Okay, so now with analytical method. So let's see. So this is very important, and we will see all the concept under this explanations whatever I am going to do here about the convolution of discrete time signal through analytical method. So let's see first. This is our what topic is convolution for two discrete time time signal. Okay, so convolution of for two discrete time signal. So how signal? So let's say I have input sequence x of n, and this is applied to the discrete time system whose impulse response is h of n, and here is my output response. Yes, so this is my output response y of n. So here in this case the input sequence is given and impulse response is also given. We have to find the output response of the discrete time signal. Okay, so how to find this output response of the discrete time system? That is y of n is equal to n is equal to minus infinite to plus infinite x of k into x of, yes, so this is my y of n is equal to, so this is my k. Okay, so it is ranging, the range is for k is equal to minus infinite to plus infinite. Okay, so sorry, so we can write this as, what is output? Output is nothing but y of n is equal to x of n convolution h of n, Then how to do this convolution in time sequence? So this is what convolution of two discrete time signal is nothing but here y of n is equal to k, summation k is equal to minus infinite to plus infinite x of k into h of n minus k, or we can write this as summation k is equal to minus infinite to plus infinite x of n minus k into h of k. Okay, so this is my what? This is my convolution of two discrete time system that we can do in this way. Okay, in this way. So these are the two. You can interchange also these two. Yes, you can reflect h of n minus k, either h of n, you can reflect either impulse response or input sequence. So that how we can observe, how we can identify that which method is suitable. So this will come by experience. Okay, so once you will do more convolution of discrete time system, then you will come to know which one is suitable for us. Okay, so we are going to see here how to find the output response for given input sequence and impulse response. So let's see, and we will see which method is suitable for us. Okay, so this is both. Okay, so both are correct. Okay, so you can do this one, also this one, as per our convenience. Okay, so let's see how to do. This is the definition of convolution. Okay, convolution operation: x of k, h of n minus k, x of n minus k, h of k. Okay, so here x of n is given as u of n minus u of n minus capital N. Okay, so this is my input sequence which is given. So my impulse response is given as h of n is equal to alpha to the power n u of n. Okay, so now we have to find the convolution between these two signal. Okay, one is impulse response and another is input sequence, which is excitation for this discrete time system, and we have to find the output sequence for this discrete time system. So which is nothing but, if you see, for me which method is suitable, that is y of n is equal to summation. Okay, so this is y of n is equal to what? Y of n is equal to x of n convolution h of n. Okay, h of n. Now which method is suitable for me? I will take, this is what k ranging from minus infinite to plus infinite. I will take first, I will reflect this input sequence x of n minus k into h of k. I will take this summation which is suitable for me to solve this convolution. Okay, so this convolution operation. Okay, so this method is suitable. This method is more convenient for me. How it is convenient that we see further. Okay, so first of all, this is x of n minus k. Now we are going to plot this signal and this signal. Then after that we will convolve this. Then after that we will do the operation of this resultant signal. Okay, so first I will plot this signal x of n minus k and h of k. So let's see, and this is my input sequence. Okay, this is my impulse response, remember this one, and I'm going to rub this total. Okay, and we are going to solve this output. Okay, so we are going to obtain this output response for given input sequence and discrete time system. And please note down it, and then you can see what is input sequence and what is impulse response. So let's see further. We have to, as I have given x of n is equal to what? X of n is equal to u of n minus u of n minus capital N. Okay, so now I'm going to plot x of n minus k. So then what should be my x of n minus k? Plot this x of n minus k, which is nothing but u of n minus k minus u of n minus k minus capital N. Yes, let's see how to design this, how to plot this signal. So this is my, so first of all what I have to do here, this is in k domain. Okay, so this is in k domain. First what we are going to do, we are going to plot x of k. Okay, so then in next step is what? X of k plus n, x of k plus n. So this is my next step, and then my final step will be x of what? X of minus k plus n. Okay, minus k plus n. So this is also very important, how to plot this signal. What I have done, what I did here, first I just changed the domain of the signal. This is time sequence. Okay, so in case of n, I just took what? K. Then after that I just shift this x of k signal by an amount of minus n, this is plus n. Then after that I have just reflect this signal by along this k axis. Okay, I just have reflect this signal along k axis. See, first I have shifted by amount of minus n, then I have reflected this signal along k axis. Okay, so this is the procedure how to plot this signal. So let's see how to plot this. Then how to plot this signal. So what we have to do here, first we have to plot this signal. This signal is what? This. Okay, x of n signal is u of n, which is ranging from where to where? N to capital N. Yes, this is my range of what? So this is 0 to n, and this is my k axis. Just you take x of k. Okay, x of k. Then you just reflect this signal. When I will reflect this signal, so then what I will get here? After reflection, then we have to reflect this signal. After reflection, what we will get here? Minus k. Okay, minus k. So minus k. So then what I will get here? See, this will get reflected. This will come total here. This signal will come this side after reflection, which is ranging from where to where? 0 to minus capital N. 0 to minus capital N. Yes, this is my x of what? X of minus k. X of minus k. Yes. Now here what I have to, now I have to shift this signal by an amount of what? By an amount of what? Plus n. Yes, by an amount of plus n. So when I will shift this signal, this is minus k plus n. So this will range from n to n minus capital N. Okay, so what you have to do? Nothing, just plot this signal first, then reflect this signal. Then after that shift that signal by an amount of n. Yes, by an amount of minus n. So then it will come like this. Okay, so it will range from minus n to minus n minus capital N to small n. Okay, so this is how we plot x of n minus k. This is final for x of n minus k. Yes, this is the final for x of n minus k. How to plot this? First you just plot this one signal, then reflect this signal. Okay, just mirror image. Then after that shift that signal by an amount of n. So here n. Shift that amount of signal by amount of, shift that signal reflected signal, shifting the reflected signal by an amount of n, okay, on the what negative axis. So here n, here what, n minus 1, n minus capital N. So this is the range. This is my final plot for this signal, x of n minus k, x of n minus k. So now see the plot for what? Plot for impulse response. How to plot the impulse response in k domain? So this is simple. H of k is equal to what? H of k is equal to alpha to the power k, u of k. Yes. So how to plot this signal? So this is very easy. Just take k domain in place of n. So this is something like this: exponentially decayed signal. Okay, exponential decayed signal. Yes. So this is 0, 1, 2, 3, 4, 5 dash dash up to infinity. This is in k domain, and this is my h of k. Yes, this we have done just plot. We did what we did here. We just took what, k in place of n, and we have plot this h of k. Yes, impulse response in k domain. Now we are going to plot simultaneously. Okay, so we are going to plot both the signal on common axis. See this common axis. Yes. So this is my, which will give me output y of n. Yes, this is on common axis, both the input sequence and impulse response. This is my k domain. What domain? K domain. Okay, so this is my impulse response in k domain. So which is nothing but exponentially decayed signal. Yes, exponentially decayed signal. So this is my one. Yes, so this is my what? H of k. And here is my x of n minus k. This is my x of n minus k. Okay, so this signal. So this is ranging from where to where? N minus capital N to n. So this is my x of n minus k. Now from this we are going to what? We are going to find the output sequence for the given input excitation and impulse response. So how? Is there any common range between these two signals? So when n is what, less than 0, for this there is no common range at all. Common range is 0. So therefore we can say that in first case what, y of n is equal to what? Y of n is equal to 0 for what? For n less than 0. Yes, when n is less than 0, my output is 0 because there is no common range between these two sequences. Okay, in k domain. So this is my first excitation signal inside the impulse response signal. That is what, how. Number 2 is what, when n is greater than 0 and n minus capital N is less than 0, which implies what? Which implies that my n is greater than 0 but less than capital N. Yes, for that my resultant plot will be like this. So this is my y of n. Okay, so this is my y of n, and here I have just slided the input sequence in k domain inside the impulse response, reflected form of the impulse input sequence inside the impulse response. So this I have slided inside. Okay, inside. So this I have slided just inside the impulse response, which is ranging from n minus n. Okay, so which is less than 0. Still it is less than 0 and it is greater than 0. Yes, and here this is my exponentially decayed signal. This. Okay, so this is my exponentially decayed signal and it is in k domain. Now is there a common range between these two signals? Yes. So this is my signal what, h of k signal, and this is my signal, which signal? x of n minus k signal. Yes, there is a common range, this one. Where to where? 0 to n. 0 to n is the common range. So therefore output sequence is obtained as what? Y of n is equal to, for k second is summation what, k is equal to 0 to n, and what is my x of n minus k? This is nothing but 1 into what is my y of h of k, which is nothing but alpha to the power k, where alpha is less than 1. So this is my alpha to the power k. Yes, now I have to solve this summation. So how to solve this summation? Let's see. So this is nothing but what? Summation is nothing but alpha to the power k. So how to solve? Let us solve this. Okay, so here I am going to rub this. Okay, so this you may have note down this work. Okay, so you just note it down, and after that okay, so where we got y of n is equal to, what? Summation k is equal to 0 to n alpha to the power k. So which is nothing but equal to what? Equal to 1 minus alpha to the power upper limit minus lower limit is nothing but upper limit minus lower limit plus 1. divided by 1 minus alpha, and finally I get what y of n is equal to what 1 minus alpha to the power n plus 1 divided by 1 minus alpha. Okay, so this is for what? This is when n is greater than 0, when n is greater than 0 and less than capital N. Okay, so this is my case second, when I have slided the input sequence. Okay, so for n greater than 0 but less than capital N. Okay, so this is my case second. Now we are going to further slide the input sequence inside the impulse response in K domain. So that is my case third. Okay, so that is my case third. In case third, what we are going to do, we are going to slide further the input signal where my n minus capital N is greater than 0 and my n is less than infinity. Yes, so which implies that n is what? N is greater than capital N but it is less than infinity. This is going to my third case. Okay, third case. First case, what we did in first case, n less than 0. Okay, we just kept n less than 0. This is my case third. Okay, for case third, n is lying in between capital N to capital N to infinity, less than infinity, greater than capital. Let's see here third case. Okay, so in third case what is there? My n is ranging from capital N and greater than capital N and less than infinity. Okay, so for this my output will be equal to what? See the plot here. This is my y of n. Okay, so y of n. So here I am going to slide. So this is my exponential signal. Okay, exponentially decayed signal. So this one, this, okay, these are my impulse and it is in K domain. So this is my this is my what? H of K. Okay, this is my H of K. And now I have slided this left sided signal completely inside this signal, which is ranging from where to where? Small n to, which is ranging from n minus capital N to n. Yes, n to n. Let's say n is here. Okay, n is here. So this signal I have completely slided inside this exponentially decayed signal. Yes, now see here, and this signal is nothing but this is my x of k. What? X of k. This is my x of k. Now is there common range? Yes, there is a common range which is lying in between n minus n to capital N. So therefore my output sequence will be equal to x of n is equal to summation n minus capital N to small n where my input is 1. This is my y of n is equal to n minus capital N to n. Okay, small n. This is 1 into alpha to the power k. Now I have to solve this summation. How to solve this summation? Let's see. For this, let us make the assumption as per our convenience. M is equal to what? This is the range for what? K. So M is equal to k minus n plus capital N. Okay, let us assume M is equal to k minus n plus capital N. So where M is ranging from where to where, put k is equal to n minus capital N. I will get M is equal to 0 and and again put k is equal to n and I will get M is equal to n. So now my new range for M is from 0 to n. Okay, so therefore we are going to solve this output sequence for this range and where my k is nothing but equal to m plus n small n minus capital N. Yes, so this is what assumption as per our convenience that we are going to make here in the summation, so that we can easily get this output sequence. Okay, so how it is, let's see. So this is M is ranging from 0 to n and k is equal to m plus n minus capital N. So let's see. I'm going to rub this. Okay, so this, now we are going to solve this summation. So let's see. So this is for the range of capital N to infinity. So my output will be equal to what? For third case, y of n is equal to summation m is equal to 0 to what? M is equal to 0 to capital N. Yes, and this is 1 into alpha to the power where k is nothing but m plus n minus k. M plus n. Yes, so this is my m plus n minus capital N. Yes, now what I'm going to do, what I'm going to do here, I just take this term n minus n, alpha to the power n minus n at outside. So here what I will get, y of n is equal to alpha to the power n minus capital N summation m is equal to 0 to what, capital N alpha to the power n. Yes, now we know this summation. Yes, so which is nothing but y of n is equal to alpha to the power n minus capital N into 1 minus alpha to the power upper limit minus lower limit, plus 1 divided by 1 minus alpha. Yes, so this is my output sequence for this range n to infinity. Yes, this is the last step for this. Okay, so now, so this is what y of n is equal to x of n convolution h of n. Yes, h of n, where my x of n was what, x of n was u of n minus u of n minus capital N, and my impulse response was what, h of n. My impulse response was h of n is equal to alpha to the power n u of n. Yes, for this input and impulse response, we found the resultant convolution as output y of n is equal to what, is equal to 0 for n less than 0 and 1 minus alpha to the power n plus 1 divided by 1 minus alpha for n greater than 0 but less than capital N, and we found alpha to the power n minus capital N, 1 minus alpha to the power what, to the power capital N plus 1 divided by 1 minus alpha. Yes, this we got for what, for n greater than capital N but less than infinity. Yes, so this was my final answer for convolution of the signal, which we have done with analytical method. Okay, so we have seen with proper explanation how to solve the input, how to solve the convolution in time sequence through analytical method. Okay, so here we have got the output resultant sequence for the given input excitations as input sequence and the impulse response of the system. Okay, so that's all for today about this concept of convolution through analytical method. So that's all for today. Thank you very much. Thank you.